Dispatchable Demand is an electricity authority initiative that enables consumers to participate more actively in the wholesale electricity market. Let's look at an example to see how dispatchable demand works. Sarah, a factory owner, wants to reduce her electricity costs by managing her load during peak price periods. She thinks signing up for dispatchable demand could help, and to get approved, she needs to consider her business and how it operates. Sarah looks at the 4 main machines at her factory. 2 of these machines are production critical and they can't be turned off without a lot of notice and planning. Sarah decides these machines aren't suitable to be part of dispatchable demand. They'll continue to run as per their normal production schedule. The other 2 machines can be turned off and on relatively easily. Sarah decides these would be good to have as part of dispatchable demand, so she invests in having these machines metered separately from the rest of her load, with a revenue quality meter. This metering equipment is a requirement for dispatchable demand participants. She then applies to the system operator to become a dispatch-capable load station, or DCLS. In her application, she indicates that the machines at her factory are binary loads, meaning that each machine operates either at 100% of their capacity when on, or 0% when off. These details allow the system operator to schedule the load correctly. Note that the DCLS configurations are decided by each participant based on their business. Even process critical machines could potentially be okay as part of dispatchable demand. Now, as part of the usual running of her factory, Sarah will enter dispatchable bids for each trading period. The bids indicate the megawatt amount of load Sarah needs to run the machines and the maximum price Sarah is willing to pay for that quantity of load. Bids can be entered in up to 10 tranches of load quantity and price. The system operator uses this information as part of its procedure to dispatch the power system. Sarah will need to comply with each dispatch instruction issued by the system operator, adjusting her electricity usage if necessary. Note that Sarah still has the choice to make her bids non-dispatchable and run production regardless of market conditions. For example, if she had a large order and needed production running at full capacity. With dispatchable demand, Sarah has a level of cost certainty for her electricity. In this example trading period, Sarah is willing to pay $500 per megawatt hour for machine 3, but only $300 per megawatt hour for machine 4. The dispatch price is calculated at $400 per megawatt hour, which is above what Sarah was willing to pay for machine 4's load. Therefore, she receives the dispatch instruction to reduce her load by turning off machine 4. At the end of a trading period, the final settlement price, which is a time-weighted average, can be higher or lower than the dispatch prices the dispatch instructions were based on. There are 4 possible outcomes for Sarah depending on the settlement price. In the first case, the dispatch instructions kept Sarah's machines on. The settlement price is below what she was willing to pay based on her bids, so Sarah pays for her actual usage at the lower settlement price. In the second case, Sarah received a dispatch instruction to keep her machines on, but the settlement price ends up being higher than what she bid. In this case, Sarah gets a constrained on payment to make up the difference between her bid price and the higher settlement price. The third outcome is that Sarah's load was dispatched off, so she did not use her machines. The settlement price is higher than her bids, so she avoids paying high electricity costs. Finally, the fourth outcome. Sarah's machines were dispatched off, but the settlement price is lower than her bid price. This means she would have been willing to purchase electricity at that price and would have kept production going. Sarah gets a constrained off payment to compensate for the production interruption. In addition to her dispatchable bids, Sarah can also offer her factory's load as interruptible load in the instantaneous reserve market. If the same load is offered as both dispatchable demand and interruptible load, this will be taken into account by the market schedules, including the dispatch solution. You can see the benefit of dispatchable demand for Sarah. She gets cost certainty as long as she follows dispatch instructions. Her business is not exposed to uneconomically high electricity prices in the wholesale market. By participating in the market, Sarah contributes to price competitiveness, which can apply downward pressure on wholesale electricity prices. In addition, Because participants are required to comply with dispatch instructions, dispatchable demand improves load forecast and schedule accuracy. Dispatchable demand also contributes to reducing peak loads as more customers are exposed to the wholesale market.